Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Arduino Epoch Learning Center, and this is Project 26. And in this video, we're going to conquer two electronic blocks, the joystick and the servo motor. Now, I've added in an extra servo motor here, and I'm actually going to work backwards this time. I'm going to do the setup after I give you the demonstration because I've got this hooked up, and I just finished the code, and this is actually super easy to do. Okay, so the vertical and horizontal of the joystick, there's two different lines, and they're just variable resistors. So what we're going to do is we're going to use the servo library, and we're going to use the vertical and horizontal variable resistors in the joystick to make one servo motor activate on horizontal and one on vertical. So if I go up and down, now if I go up, down, watch the direction, up. If I do it really slowly, down. But if I go left, left, and right. So now if I just start swirling it all around. Very neat, huh? Now again, this board wasn't designed for two servo motors, and we do put a little bit of stress on the 5-volt regulator when we have two servo motors constantly working. So if you're going to make this project, you don't need to use two servo motors, and we'll in the future use the joystick again. It's a very simple project, but basically what happens is we declare in the code, we declare our servo and servo B. So my servo and my servo B, and we use two analog pins, analog pin 0 and 1, one for the vertical and one for the horizontal, and they connect right here. The servo motor connects to GPIO pins 9 and 10. And so it's actually really easy to control a servo motor because with the library it's as simple as what is the command? My servo, or whatever I've named my servo dot right, and then in brackets what number between 0 and 180 degrees. So because each of these variable resistors go to the analog lines that we see between 0 and 5 volts, it's a 10-bit analog to digital converter, so we see between 0 and 1023. And so because 0 counts as a number, it's really 1024. So in the code we say position or equals whatever the analog reading is, and divide that by 6. And why do we divide by 6? Because 1023 is obviously a lot bigger than 180 degrees. So what I did was I divided 180 degrees, or 1024 by 180 degrees, and I got 5.68, I believe, and I just rounded up to 6. So I divided it, so I basically said 1 degree for every value of decimal value of 6. So I made it manageable. So as you can see, if I go left, it goes about 90 degrees right. If I go right, 90 degrees left, or negative 90 degrees. It doesn't go the full 360 degrees. These ones do not anyway. These are micro servos. One comes with the kit. You can just comment out the code. In fact, when I upload the code to the website, I'll just comment out this part of the code for the second servo. Well, if you have yours, you can feel free to do that. What you can also do is you could, if you want, here's a challenge, is to connect the vertical and horizontal to analog pins 0 and 1. And use the serial monitor to read out the values as they change when you when you mess with the joystick. So you can read both the horizontal and vertical data as you go. Now, when it's sitting right in the middle, I believe both vertical and horizontal sit at something like 500, so 2.5 volts. And of course, if I go all the way this way, it's in the entire 5 volts. If I go this way, it's 0 volts. If I go up, 5 volts. If I go down, 0 volts. And so when it sits in the middle, about 500 in both directions. So it's constantly staying in the current spot because it's sitting at about 90 degrees according to the software. It's sitting at half of 1024 roughly. So hopefully that's not too complicated. I hope that by this point, by Project 26, if you've been following along, this isn't too complicated. The code is certainly very simple. And just here's another challenge: get rid of the joystick. Create a combination lock. Now remember, Project 14, I believe it was, we made a combination lock that activated a relay. Use Project 14 again. I think it's Project 14 off the top of my head. The combination lock using the analog keypad. Use that in this code to create a servo-based combination lock. Now I know if you've made it to Project 26 that you can do it. It's really not too difficult, and if you do it, make a YouTube video and show me. I'd love to see it. I sincerely will watch it. In any case, thanks again. The Kickstarter is now over. After 2 weeks have gone by, but 1 week has gone by, the project page will be password protected for those who have pledged. But if you haven't pledged, I'm not going to lock that down until the end of next week, so you can feel free to go ahead and check out the code. But you'll have to do it through the Kickstarter, because that is where eventually I'll have links to sell these, obviously long after the rewards have shipped out. Many thanks to all of you who pledged towards the campaign. This is the first post-campaign project, and I can't tell you guys how humbled I am to have had such a successful project. I've done 35 Kickstarter campaigns, and this one is knocked every other one out of the water. Even the Little Buddy Talker. Little Buddy Talker did 18,000, and this one just more than doubled that. So thank you all sincerely. I hope you like this project. It's a simple one, but it's a nice light project, and there's so many possibilities. Make yourself a combination lock. Do something fun with a servo. It's too easy to use. Read the comments in the code. Thanks for watching, everyone. Actually, I haven't even told you how to set up this project yet. I apologize. So I'll set up the project now. I'm going to rip everything apart. Okay, servo motor is a power beast. When it's moving, it takes a lot of power. Which is why I suggest only using one. But if you're using two, you can use it in moderation. Just don't put don't constantly be using it, because you do put stress on the 5-volt regulator. Anyway, there's a little 2-pin connector here called ServoCon, and that applies power to this 3-pin header. This 3-pin header is where you connect the servo motor, and there's 3 pins labeled ORN for orange, red and BRN for brown. There are 3 pins. Orange goes in the bottom from this perspective. Brown goes in the top. Brown is ground, red is 5 volts, and orange is signal. So, we want to connect our signal, which is right here labeled servo, to pin 9. Now we want to connect, doesn't matter really which one, but if we're going to use 2 servo motors, we can use the vertical and horizontal. I'll use the vertical. You can choose whatever you want, and I will connect that to analog pin 0. So, done. So, what if we want to use the second servo motor? We'll connect the horizontal to analog pin 1, A1, right here. It's all labeled. So don't worry if you can't see it. You'll be able to see it if you have an Epoch in front of you. So now I've got another servo with a male to female connector cables. With some connector cables, I'll connect red to the 5-volt pin on the power supply rail right here. I'll connect brown to ground, and I'll connect orange to GPIO pin 10. And I'll power it up. We'll see if everything's hunky-dory. Best David Bowie album, by the way, in my humble opinion. And so, let's just see. Everything good? Nope, looks like there's a problem on this one. What did I do wrong here? Let me just look at it from a different perspective here. Oh, I connected 10 and 11, not 9 and 10. So, that should do it. And that's it. It's too easy to hook up. Again, since the Epoch is only supplied with 1 servo motor, that will be what you have off the bat, and you can adjust this if you want. Right now we are connected to analog pin 0 is connected to vertical. The servo motor isn't like that. See, now it's reading a weird reading, and so it's all over the place. So I'll connect the horizontal to analog pin 0. As you can see, you can mess with it as you see fit. But again, this is just an introductory video. As long as you understand that the joystick is just two analog, it's two variable resistors, it's 2 pots. 0, 5 volts, 2.5 volts by default. 2.5 volts, it's not connected to anything, but 5 volts and 0 volts. And that's it. It's too easy to use. I realize I got a little convoluted in the end there. A little bit of a sloppy video, and for that I apologize. Lazy Saturday afternoon. I have the morning off tomorrow morning, so I'll try to get another project done tomorrow. I really wanted to get into the SD card, but we'll see. There's still a few electronic blocks left. I was actually puttering with the Epoch yesterday, doing a personal project, creating my own communications protocol. There's SPI, there's I2C, there's really hundreds of communications protocols, but I like tinkering around with my own. I like to create my own because then I'm in full control. But I2C is obviously, my communications protocols aren't anywhere up to snuff compared to I2C, but I find them more manageable because I designed them. I know how they work, and my dream is that really this board will help you to create your own projects. And if your kids are using this, I really hope it inspires them to go to school for electronics or software design, because I got to tell you, the endorphins that come with designing something, really, I'm at my happiest when I'm designing. So thank you so much for watching. I hope you have a wonderful Saturday. Take care, and to those of you who pledged towards the Kickstarter campaign, thank you again. Take care, everyone.